Let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool. Hello everyone. I'm PS Chatterjee, and a warm welcome back to my channel. Before we dive in, a quick note for my non-civil engineer viewers: while we'll be tackling some technical concepts today, please feel free to follow along. Just treat the engineering terms as numbers and focus on applying the Excel process to your own DIY spreadsheet projects. If you run into any problems, leave a comment below. I'll do my best to help you out, free of charge. In my last videos, we thoroughly covered the theoretical aspects and design of a doubly reinforced beam for bending stress, shear stress, and a part of deflection. We first covered this through a detailed PowerPoint presentation and then applied it in Excel. Today's video is titled Deflection Check in Doubly Reinforced Beam. IS 456 Part 04B. It's a continuation of Part 04, an Excel presentation, and a perfect DIY project, especially for my fellow civil engineers. If you're new to the channel, for a clear understanding of the series, I highly recommend checking out Part 1 to Part 4A of the series first. And for an even stronger foundation, my IS 456 Singly Reinforced Beam Design, Bending Moment, Shear Force and Deflection Limits and Checks in Excel series, Parts 1 through 7, will be incredibly helpful. In this sub-episode, we'll prepare a modified table of the modification factor, KT, for a singly reinforced beam. I've modified this table to make it compatible with dynamic interchangeability between singly reinforced and doubly reinforced beams. The basic formula will remain the same as before. Along with this table, I've developed a table for KC, the modification factor, for a doubly reinforced beam. Let's now move to our next slide. Now it's recapitulation time for Part 04A. We're going to dive into the application of formula number 22, which is the very last formula of the table named as Table for the calculation of deflection for singly and doubly reinforced beams. The explanation. Now, I have selected the formula number 21. Formula for deflection check of cantilever beam, in this formula box. In this formula, except for the first if function, the rest of the formula is the same as previous. In formula 20, we observed the first if function helps us to find the particular text from B6, and the text is n/a. But for a cantilever beam, we can also find this text n/a in cells B7, B8, C7, and C8. That is why here I have used the OR function along with the if function. And we are seeing, equals to, if, open parenthesis for first if function, or, open parenthesis for OR function, cell B7 equals quote n/a quote, comma, C7 equals quote n/a quote, close parenthesis for OR function, comma, quote n/a quote. The simple meaning of this portion is, if cells B7 and C7 contain the text n/a, Excel will type n/a in this cell. Now, we are seeing the formula number 22. Formula for deflection check of overhang cantilever beam, in this formula box. This formula is exactly the same as formula number 21. The only differences in this formula are the referred cells. In formula 21, we used B7 and C7 as references. Here, we have to use B8 and C9. Hence, for the same reason, I am skipping the explanation of this formula. So, we completed the explanation for formulas for deflection check for all four conditions and also completed the table with the title, Table for the Calculation of Deflection for Singly and Doubly Reinforced Beam. Now, our next mission is to explain the formulas for modification factors for singly, K_T, and doubly reinforced beam, K_C. Stay tuned. Now, I am switching over to the next sheet. Name of this sheet is table_F. And you are seeing the table, F, percentage of tensile steel and modification factor KT. Those who followed the video series for singly reinforced beam design series, are familiar with this table. This table helps us to calculate the modification factor K_T for singly reinforced beam. Since, presently, our beam is a doubly reinforced beam, this table is blank. To customize this table accordingly, I have changed the formula structure for Fs, and that formula you are seeing in the formula box, and the formula is, value of Fs, equals to, if, open parenthesis for if function, n, open parenthesis for n function, design_code, equals to, 1, comma, check_03, equals to, quote, OK, quote, close parenthesis for n function, comma, fs, comma, blank quotation, close parenthesis for if function. Here by adopting first part, here we are commanding Excel to check the design_code and check_03, if Excel finds the value of design_code equals to 1, and check_03 equals to, OK. Then it will transfer the value of Fs in this cell. Otherwise cell R4, will remain blank. Now, to customize all other cell, we have to type equals to, if, open parenthesis for if function, cell $R$4, equals to, blank quotation, comma, blank quotation. After this we have to write the formula for the calculation. As a result of this, if Excel finds the cell R4 as a blank cell, it will keep the cells as blank. Otherwise, it will calculate the value according to the formula in it. Now, I am switching over to the next sheet. Now, we are on the sheet, named as table, K_C, and name of the newly built table that we are seeing in this sheet, is, percentage of compression steel and modification factor Kc. Below this table, once again we are seeing the formula box, contains the formula for each cells. First, look at the table below the table heading. Here we are seeing the value of modification factors for doubly reinforced beam, Kc, with respect to the percentage of compression steel used to design the doubly reinforced beam. This chart, I have derived from, figure 05, of IS 456, 2000. Now, I am going to select the formula 1 for, percentage of compression steel provided, or in short, PCPROV. And the formula is, equals to, if, open parenthesis for if function, n, open parenthesis for n function, design_code, equals to, 2, comma, check_03, equals to, quote, OK, quote, close parenthesis for n function, comma, P_C_pro, comma, blank quotation, close parenthesis for if function. Here, we are instructing the Excel, if Excel finds, design underscore code, equals to, 2 and check underscore 03, equals to, OK, then type the value of P underscore C underscore Pro, or percentage of compression steel provided, in this cell. Otherwise keep the cell blank. Presently, we are seeing the value of P underscore C underscore Pro in this cell is 1.206%. Even when Excel will find design underscore code, equals to, 1, and check underscore 03, equals to, OK, it will keep the cell blank. Because here we used AND function. For AND function, all the arguments need to be true. Now, I have selected the formula 2 for PCPROV down in this formula box. Here, PCPROV down is the value of one step down value of P underscore C underscore Pro, or percentage of compression steel provided. And the formula we are seeing in the formula box, is, equals to, if, open parenthesis for if function, and, open parenthesis for AND function, design underscore code, equals to, 2, comma, check underscore 03, equals to, quote, OK, quote, close parenthesis for AND function, comma, lookup, open parenthesis for lookup function, P underscore C underscore Pro, comma, $B$, 2, colon, $, and $, 2, close parenthesis for lookup function, comma, blank quotation, close parenthesis for if function. First portion is same as previous formula, hence I am skipping the explanation of this portion. In the second portion, Excel will look up that value, whose value will be one step down of the value of P underscore C underscore Pro, on this table, by the help of lookup function. Here P underscore C underscore Pro, is the lookup value and $B$, 2, colon, $, and $, 2, is the lookup array. Now, we are seeing the formula number 03. Formula for PCPROV up, in the formula box. Here, PCPROV up is the value of one step up value of P underscore C underscore Pro. And the formula is equals to, if, open parenthesis for if function, and, open parenthesis for AND function, design underscore code, equals to, 2, comma, check underscore 03, equals to, quote, OK, quote, comma, C5, greater than, PC underscore PROV underscore down, close parenthesis for AND function, comma, open parenthesis for calculation, PC underscore PROV underscore down, plus, 0.25, close parenthesis for calculation, comma, blank quotation, close parenthesis for if function. Explanation of this formula, here we are, instructing Excel to search, whether the design underscore code, equals to, 2, and check underscore 03, equals to, OK, and value of the cell C5, greater than, PC underscore PROV underscore down. If all the arguments are in true, then Excel will calculate the value of PC PROV up, by adding 0.25 with PC underscore PROV underscore down. Otherwise it will keep the cell blank. You may ask, why we are adding 0.25 with PC underscore PROV underscore down. You will find that answer on PowerPoint presentation on deflection check for doubly reinforced beam. Formula number 04. Formula for KC down. KC down is the modification factor with respect to PC_PROV_ down. In the formula box, we are seeing the formula for KC down, and the first portion of this formula is exactly same as formula number 01 and 02. The full formula is equals to if open parenthesis for if function and open parenthesis for n function design underscore code equals to 2, comma check underscore 03 equals to quote okay quote close parenthesis for n function comma h lookup open parenthesis for h lookup function PC_PROV_ down comma $a$ 2 colon $and 3 comma 2 comma 0 close parenthesis for h lookup function comma blank quotation close parenthesis for if function. Simple meaning of this formula: here we are instructing the Excel if Excel finds design underscore code equals to 2 and check underscore 03 equals to okay, find the value of KC down by the help of h lookup function of Excel. Here lookup value is PC_PROV_ down, lookup array is $a$ 2 colon $and 3, lookup row is 2 and 0 for exact match. Otherwise keep the cell blank. Presently, we are seeing the value of KC down in this cell is 1.250. It has no unit. It is just a multiplier. Formula number 05. KC up. KC up is modification factor with respect to PC_PROV_ up. The full formula is equals to if open parenthesis for if function and open parenthesis for n function design underscore code equals to 2, comma check underscore 03 equals to quote okay quote close parenthesis for n function comma h lookup open parenthesis for h lookup function PC_PROV_ up comma $a$ 2 colon $and 3 comma 2 comma 0 close parenthesis for h lookup function comma blank quotation close parenthesis for if function. This formula is exactly same as the formula number 04. The only difference in this formula is lookup value. Here lookup value is PC_PROV_ up instead of PC_PROV_ down. Formula number 06. KC. KC, or final modification factor with respect to PC_PRO. It is the interpolated value between KC down and KC up. By the help of Excel function define name, I have defined name of this two cell as KC_1 and KC_2, respectively. And the formula we are seeing in the formula box is equals to if open parenthesis for first if function and open parenthesis for first n function design underscore code equals to 2, comma check underscore 03 equals to quote okay quote comma C5, greater than, PC underscore PROV underscore down, close parenthesis for n function, comma, KC underscore 1, plus, open parenthesis for calculation, C5, minus, PC underscore PROV underscore down, close parenthesis for calculation, multiplied by, open parenthesis for calculation, KC underscore 2, minus, KC underscore 1, close parenthesis for calculation, divided by, open parenthesis for calculation, PC underscore PROV underscore up, minus, PC underscore PROV underscore down, close parenthesis for calculation, comma, if, open parenthesis for second if function, n, open parenthesis for second n function, design underscore code, equals to, 2, comma, check underscore 03, equals to, quote, okay, quote, comma, C5, equals to, PC underscore PROV underscore down, close parenthesis for n function, comma, KC underscore 1, comma, blank quotation, close parenthesis twice for two if functions. Now, it is the time to explain the above formula. The explanation is, in the first portion of this formula, we are instructing the Excel to observe the value of design underscore code equals to 2 and check underscore 03 equals to OK and cell C5 or PCPROV greater than PC underscore PROV underscore down or not. If Excel finds all the arguments are true, then Excel will calculate the value of KC by following the equation KC underscore 1 plus within bracket C5 minus PC underscore PROV underscore down multiplied by within bracket KC underscore 2 minus KC underscore 1 divided by within bracket PC underscore PROV underscore up minus PC underscore PROV underscore down. If Excel finds any of this argument as a false argument, it will search in the second portion for the value of KC. In the second portion of this formula, we are instructing the Excel to observe the value of design underscore code equals to 2 and check underscore 03 equals to OK and cell C5 equals to PC underscore PROV underscore down or not. Once again, if Excel finds all the arguments are true, then Excel will calculate the value of KC by returning the value of KC underscore 1 as KC. If Excel finds any of these arguments in these two sets of the formula as a false argument, it will keep the cell as blank, as if Excel is saying, so we finished our task for the preparation of percentage of compression steel and modification factor KC table. Once again I am returning to the sheet, design underscore 01. Stay tuned. Now, we are on the sheet named as design underscore 01. You can say this as a dashboard for beam design. In this dashboard we will accumulate the data from other sheets, such as effective length of the beam, L underscore EFF, basic ratio of effective length and effective depth, basic underscore L underscore EFF underscore D underscore EFF, modification factor, K underscore T or KC, allowed effective length, L underscore EFF underscore allow, and deflection check. All from the sheet named as defl_cal. To do that, we have to use VLOOKUP function. Now, in the formula box we are seeing the formula number 05, for calculated value of L_EFF, in this sheet, and the formula is equals to, if, open parenthesis for if function, beam_code, equals to, blank quotation, comma, blank quotation, comma, VLOOKUP, open parenthesis for VLOOKUP function, beam_code, comma, quote, DEFL_CAL, exclamation mark, quote, $A$5, colon, $F$8, comma, 2, comma, 0, close parenthesis for VLOOKUP function, close parenthesis for if function. Simple meaning of this formula is, if Excel finds cell named as beam_code is blank, it will keep the cell named as L_EFF as a blank cell. Otherwise, it will bring the value of L_EFF from sheet named as DEFL_cal by VLOOKUP function, and in this function, beam_code is the lookup value, quote, DEFL_CAL, exclamation mark, quote, $A$5, colon, $F$8, is the lookup range, the value 2, is the column index number, 0, for exact match. Now, in the formula box I am changing the formula number from 05 to 06, and we are seeing the formula number 06, for the calculated value of basic_L_EFF_D_EFF. This formula is exactly same as formula number 05. The only difference in this formula is column index number. Here it is 3, instead of 2. Now, in the formula box I am changing the formula number from 06 to 07, and we are seeing the formula number 07, for the calculated value of modification factor, K_T or Kc. This formula is exactly same as formula number 05 and 06. The only difference in this formula is column index number. Here it is 4, instead of 2 or 3. Now, in the formula box I am changing the formula number from 07 to 08, and we are seeing the formula number 08, for the calculated value of allowed effective length, L_EFF_allow. This formula is exactly same as formula number 05, 06, and 07. Once again, the only difference in this formula is column index number. Here it is 5, instead of 2 or 3 or 4. Now, in the formula box I am changing the formula number from 08 to 09, and we are seeing the formula number 09, for deflection check. This formula is exactly same as formula number 05, 06, 07, and 08. Once again, the only difference in this formula is column index number. Here it is 6, instead of 2, 3, 4, or 5. Formula number 10. For conditional formatting of the support 1. This cell named as B_1. Actually we have to make this B_1 and B_2 redundant during the calculation of a cantilever type beam. Because we know effective length of cantilever beam equals to clear span of the beam plus half of the effective depth. Here support 1 and support 2 have no role. but support B_1 has a role during the calculation of effective length of the overhang cantilever beam. Effective length of overhang cantilever beam equals to clear span of the beam plus half of the support width. Formula for conditional formatting is equals to open parenthesis beam_type equals to quote 3 cantilever quote close parenthesis. Then by selecting the cell B_1, we have to put this formula in the formula box, use a formula to determine which cell to format, by choosing this option, and we have to choose the dark gray color for cell as well as for font. As a result of this, when we will choose the cantilever as a beam type, dark gray color will fill the cell and font. As a reminder of no requirement of this parameter in this calculation. But for overhang cantilever beam it will remain as a white colored cell, to remind us that the value of support width is required. Formula number 11. For conditional formatting of the support 2. Name of this cell is B_2. During the calculation of a cantilever type beam or overhang cantilever beam, we know, this support will remain redundant. Formula for conditional formatting for this cell is equals to open parenthesis or open parenthesis for or function beam_type equals to quote 3 cantilever quote comma beam_type equals to quote 4 overhang quote close parenthesis for or function close overall parenthesis. Then by selecting the cell B_2, we have to put this formula in the formula box of the use a formula to determine which cell to format by choosing this option, and we have to choose the dark gray color for cell as well as for font. As a result of this, when we will choose the cantilever or overhang cantilever as a beam type, dark gray color will fill the cell and font. As a reminder of no requirement of this parameter in this calculation. Formula number 12. For conditional formatting of the cells with heading, effective length, basic ratio of modification factor and effective length allowed. Formula for conditional formatting for these cells is equals to open parenthesis or open parenthesis for or function beam_type equals to quote n/a quote comma check_04 equals to quote check quote close parenthesis for or function close overall parenthesis. Application of this formula is same as previous, only difference is, instead of dark gray fill we have to use yellow fill. As a result of this, when we will choose any beam type, and in the cell named check_04, if we find the text check or n/a, the cell will be filled with yellow fill. Formula number 13. For conditional formatting of the cells with heading, deflection check. We provided the name of the cell as check_04, by the help of define name feature. Formula for conditional formatting for these cells is, equals to, open parenthesis, n, open parenthesis for n function, beam_type, not equal to, blank quotation, comma, check_04, equals to, quote, OK, quote, close parenthesis for n function, close overall parenthesis. Here, meaning of the less than and greater than symbol together with is, not equal to. Application of this formula is same as previous, only difference is, instead of yellow fill we have to use green fill and base color will be yellow fill. Alright, that wraps up deflection check in doubly reinforced beam. IS 456 Part 04B. Today, we successfully completed our dynamically interchangeable Excel sheet for both doubly and singly reinforced beam design for deflection checks. Instead of adding more time to this video, I'm saving the sheet testing for the next one. And trust me, when we test it, it's going to work beyond our expectations. Your free Excel sheet. Now, for an announcement many of you have been waiting for, the free Excel sheet I demonstrated previously, the one without detailed explanation. I've received so many fantastic emails, and I'm genuinely thrilled to share it with you. To get your copy, please read the instructions carefully in the description below this video. It's a quick two-step process. You'll need to email me your request and leave a comment on this specific video letting me know you've sent it. Both steps are absolutely essential. And once you've got the file, a quick "got it" or "thank you" would be a huge sign of gratitude for my honest effort. You're ready to pay it, aren't you? I definitely believe so. Empower your learning. For this entire beam design series, my main goal is to empower you to build your own Excel sheet. Relying solely on pre-made sheets can limit your understanding. Developing your own truly builds your skills and confidence. If you hit any snags while creating your sheet, remember, I'm here to help you completely free of charge. My focus is always on your learning and skill development. Support my work. If you'd like to support what I do, here are two simple ways. Watch my videos in full. Consider a contribution, whatever fits your budget, without any pressure. You'll find the details in the description, and the communication process is the same as requesting the Excel sheet. Your engagement genuinely helps me improve how I share knowledge with all of you. Stay engaged and support the channel. I hope you enjoyed this episode. Please leave your feedback and questions in the comments below. If this video helped you, give it a big thumbs up. Remember, sharing knowledge means enhancing knowledge, so please share this video. And if you want to support my honest effort, subscribing to the channel is the best way to do it. Subscribe for mutual benefit. Thanks for your cooperation and support.